Alright, so far we've talked about systems of equations with just two variables. We've done linear and nonlinear, and now I want to talk about systems in three variables. And it's not that much different than doing it in two variables. What it means graphically, you're really talking more about planes, and so we'll talk about that in class, what it means graphically. But the algebra using elimination is pretty much the same. We want to eliminate one variable, and then we're going to eliminate another variable. It's just an extra step. So in all of these, whenever I give it to you listed out as three equations like this, we're going to label this equation 1, the very top one, the middle one will be equation 2, and then the bottom one will be equation 3. That way we know what we're talking about. What I typically do is I group the top two equations, equations 1 and 2 together, and I eliminate a variable. And then I group equation 2 and equation 3 together, eliminate the same variable, and I'll come up with two new equations between doing both of these steps. And then I just treat it like we've always done with linear systems of inequalities, or not inequalities, but equalities. So for this first one, I want to add and eliminate a variable. I'm just going to so happen to choose, it doesn't really matter to me, the x. I want to eliminate x on everything. So to eliminate the x's here, I'm going to multiply everything in the top equation, equation 1, by 4. And that gives me negative 4x plus, no, not plus, we got a negative 5 there, don't we? Negative 4x minus 20y minus 20z is equal to 8. So I just multiplied everything right here by positive 4. The bottom can stay the same because, or equation 2 can stay the same because I know that these two will add up and give me something that eliminates the x. So minus 5y plus 4z equals 19. Now all I'm going to do is just add these two equations. This will eliminate the x's and give me negative 25y minus 16z, and then 8 plus 19 gives me 27. So this is my new equation, alright? Brand spanking new, I'll call him equation 4. Now I'm going to take equation 2 and equation 3 and eliminate the x's. So what do I need to do here? I'm going to multiply the bottom equation by negative 4. And then I know 4x minus 4x will also cancel out. So writing this out, I get 4x. The equation 2 stays the same. I can just copy him over again. And then equation 3 I multiply by 4. I get 4x plus 20y minus 4z equals 80, negative 80. So just double check. This can be real tedious. That's probably the hardest thing about it. Sometimes you make mistakes when you try to go through it too fast. So notice for once I just made one. I multiplied everything by positive 4. It needs to be multiplied by negative 4, doesn't it? So that becomes negative. Let's multiply everything by negative 1. No big deal. But that's why we check, because when I add, the x's need to cancel. So 4x minus 4x gives me 0 x's. So they just canceled. Negative 5y minus 20y gives me negative 25y. And then 4z plus 4z gives me 8z's. And then 19 plus 80 gives me 99. And this is a new equation. I'll call it equation 5. So now what I'm going to do is I'm going to take equation 4 and equation 5 and write them together as a new, kind of like a new systems of equations. Negative 25y minus 16z equals 27. That's equation 4. Equation 5 is negative 25y plus 8z equals 99. Now, we want to eliminate it again, and it looks like they've set this up so the y's are going to eliminate very nicely here. But I need to change the sign. So I'm going to multiply the bottom one. You can multiply the top if you want. I'm going to multiply the bottom one by a -1. That's going to flip all the signs here. And then I'm going to add straight up and down. So -25 plus 25 will eliminate the y's. -16 minus 8 is going to give me -24z. And then 27 and a -99 there is going to give me -72. And then divide both sides, divide both sides by -24, which it looks like z is going to come out to be +3. So I have found the value of z, but I'm not done. I still need to know what x and y are. So to find x and y, what I need to do is substitute 3 back in for z here. So this 3 could go into any of these equations, and I picked two of them. Excuse me, equation 1 and equation 2, you could substitute 3 in and solve for x and y. You could put it into equation 2 and 3. So put 3 in there, and then solve for x and y there. You could also come over here, put 3 in for z, and solve for y. So that's what I'm going to do right here. I'm going to say, if I let z equal 3, then this becomes -48, because 3 times 16 is 48. It's a negative, so it becomes -48. I'm going to add 48 to both sides. So this became 3, and then I'm going to add 48 to both sides. That would cancel that out. And this gives me what? So 60 looks like 75. So 75 is equal to -25y. So y is equal to -3. So z equals 3, y equals -3. And then I need to solve for x. So I'm going to pick the, I don't know, I'll pick equation 3 here. I know z is 3, y is -3, so that makes this -15. And I'm still solving for x, and all this equals -20. -15 minus 3 is -18. I'm running a little out of space here, but that's okay. Add 18 to both sides, and I get x is equal to -2. So in this case, we got z equals 3, y equals -3, x equals -2. And if you want to check, you could substitute those 3 values into all 3 equations here, and they should give you these 3 numbers here on the right. Okay? If for some reason you have no solution, you're going to have some things come out strange, like you've done in systems of equations in the past. Like you'll solve for something and get -5 equals 4. Or if you have infinitely many solutions, you'll see, like we've seen in the past, where 4 equals 4, a true statement after things get eliminated. Let's try out one more here. So I want you to pause the video, try it out for yourself, see if you can get the value of x, y, and z. Or if you want, let me see, what do I want to eliminate? You can really eliminate anything that you want. I'll choose to eliminate the z's this time. So if you want to see how I set it up, you can pause the video, try to eliminate z and come up with 2 new equations, and then see what we get. So here's equation 1, equation 2, and equation 3. I'm going to put equation 1 and 2 together first. And if I want to eliminate the z's, that means I need to multiply, I'm going to multiply the top one by -2. So this gives me positive 8x, and then positive 10y, positive 2z, and then -36 is what it's equal to, because I multiplied everything there by -2. The bottom one can stay the same, so I get -2x minus 5y minus 2z is equal to 12. I'm just going to add straight up and down there. And this gives me 6x plus 5y. The z's cancel, which is what I wanted. And that all equals no, not a positive, but a negative 24. This is, we'll call it equation 4. For equation 2 and equation 3, we want to eliminate the z's. Not a big deal there. I can just, notice they're already opposites there. I can just add them right there. So negative 2x minus 2x gives me negative 4x. Negative 5y plus 5y. Hey, the y's cancel out there. That makes life a little bit easier. So do the z's. And we get negative 4x is equal to 16. So actually, I don't even need, this one works out to be a little bit easier. I didn't see that off the bat. If you divide both sides by negative 4, you get x equals negative 4. Well, if x equals negative 4, that's one of the 3 variables I have to find, I can now substitute him in over here and solve for y. So 6 times negative 4 gives me a negative 24 plus 5y is equal to negative 24. So if you add 24 to both sides, you get 5y is equal to 0. So y equals 0. And so now all I got to do is solve for z. So I'm going to just pick an equation. I'll pick equation 1 and solve for z. So negative 4 times negative 4 gives me positive 16. Negative 5y times 0 gives me 0. And then when I subtract z, I get 18. So that means that negative z is equal to positive 2. I just subtracted 16 from both sides. And so z equals negative 2. And there we are. We've got all 3 taken care of there. That one was pretty easy. Let's do one more. I know you're excited to always do more, right? Once again, pause the video. Like I said, it doesn't matter which one you want to eliminate. I'm going to pick, and if you want to do a different one, that's fine. I'm going to eliminate the y's, because notice they all have the same coefficients. So I think the y's might be the easiest to eliminate here. So pause the video and see what you get there. So calling them equation 1, 2, and 3 again, I'm going to combine equation 1 and 2. Let's see, the y's have a leading coefficient, not a leading coefficient, a coefficient that's negative. I just need to change the signs on one of them. So I'm going to do that with the equation 1 there. So this gives me, multiplying by negative 1, x plus 5y minus z equals negative 17. For equation 2, he's fine like he is. I'm just going to rewrite him over here. Negative 5x minus 5y plus 5z is equal to 5. And so now I'm just going to add those and get my new equation. It's going to give me a negative 4x, the y's cancel like I want, plus 4z is equal to negative 12. That is equation 4. So I've got my pen. It's starting to look very rough as far as my penmanship, doesn't it? Let me read it so in case you can't read it. Negative 4x plus 4z equals negative 12, and I'm calling that equation 4. All right, this is no special symbol here. I'm just trying to make sense of it. So now the y's will cancel out if I just add these two equations right here. So that's what I'm going to do. Negative 5x plus 2y gives me negative 3x. These guys cancel. That's beautiful. 5 minus 3 gives me 2. And then this equals negative 5. This is equation 5. And so now I'm going to combine equation 4 and equation 5. Notice neither one has a y in it, and it becomes like a system like you're used to. So I've got negative 4x, negative 3x, 2z, 4z, and I got to pick one and eliminate one more variable. So I'm going to choose to eliminate the z's because I notice that 2, if you multiply by 2, you get 4. So if I multiply it by -2, I'll get -4, and then when I add them, the z's will eliminate. So I'm going to pick equation 5 and multiply everything in equation 5 by -2. And just to save space, I'm going to write it right underneath equation 4 and add from there. So -2 times -3 down here gives me positive 6x. -2 times 2z gives me -4z. -2 times -5 gives me positive 10. And then when I add these, I'll get 2x, these will cancel, is equal to -2. So x equals -1. There's one of my variables. And then I'm going to go back and substitute in right here to solve for z. If x equals -1, then this is 3 plus 2z equals -5. So 2z equals -8, and z is equal to -4. No, I'm not boxing, flowering today. I'm just drawing boxes. So I know x, I know z, now it's just time to find y. So if I put -1 in right here into equation 1, and can do it with any three of these equations, I'm just choosing equation 1 because there's room to write above it, I get positive 1. I don't know what y is. I know z is -4, and this equals 17. So 1 minus 4 is -3. So if I add 3 to both sides, I get -5y equals 20. So y equals -4. All right, there's my third variable right there solved for. So I've got 6 problems for you to try out. I've done 3 of them for you. And then I've got about a few more to do for you to do for homework, and I've got the answers there for you. So I want you to just crank out these problems, give them a try, and if you have any questions, we'll discuss them tomorrow in class. Okay? Thanks for watching, and good luck with your work.